Hello friends, we'll continue with the problems on general force system. So here is the problem. Determine the resultant of the system of forces as shown in figure. Locate the point where the resultant cuts the base AB. So in this way problem is given. So this is the system of 5 general forces. So using method of resolution, first of all it is very important to redraw this diagram. So as per the first step involved in the method of resolution, okay. So first step is nothing but you have to resolve the forces along the x and y direction, okay. So in this case, after redrawing of this diagram, see how many inclined forces are there. So here is the first force, 80 Newton, that makes an angle 60 degree with the horizontal line. You need to resolve this force in horizontal direction as well as in the vertical direction, okay. So horizontal component of this force is nothing but here 80 cos of 60. Then what's about the vertical component of the same force? 80 sine of 60. Similarly, this force also makes an angle 30 degree with the horizontal line, okay. So you need to resolve this force into its components. Now look towards this force, 100 Newton. The horizontal component of this one must be 100 cos of 30, because the component adjusted with the angle is nothing but the cos component, and the remaining one is nothing but the sine component. Now here is the another force with us in inclined direction, that makes an angle 75 degree with the horizontal line. So component of this one along the horizontal direction is 120 cos of 75, and another component of the same force in vertical direction 120 sine of 75. Now apart from this one more force is here, that also in inclined direction, okay. So what's about the component of this force along the horizontal direction? 150 cos of 50. And what's about the component of the same force along the vertical direction? 150 sine of 50, in this way. So this force already with us in vertical direction, okay. Now once the resolution part is over, now you can start the step by step. Here in the first step we can get the resolution of the forces. After that, summation of all the forces along the horizontal direction. Now focus on one by one force that available with us in horizontal direction, okay. So first one is written here, 100 cos of 30. Just look to us here, 100 cos of 30, okay. From this one the force actually considered here. So this force running towards the right direction, this force is considered as positive. Now next force is here, 150 cos of 50. This force also running towards the right direction, so this force also considered as positive. Then next force is here in the horizontal direction, whose magnitude 120 cos of 75 with us. This force running towards the left direction, okay. So give the minus sign for this one. So apart from this one, next force with us whose magnitude 80 cos of 60 running towards left direction, give the minus sign for this one, okay. Now if you do the calculations for the same, we can get the 111.96 Newton, okay. Now in the next step you have to just get the summation of all the horizontal forces. So let us consider this one is nothing but the first one, 100 sine of 30 running vertically in the upward direction. Consider this force as positive. 100 sine of 30 like this. Sine of 30, okay. This one force with us in vertical direction. Apart from this one, next force with us 80 sine of 60 vertically in the downward direction, give the minus sign for this one. So next force with us here 120 sine of 45. This force with us in vertical direction, give the plus sign for this one. Next force with us vertically in the downward direction, give the minus sign for this. The next force with us 150 sine of 50. This force also with us in vertically downward direction, give the minus sign for this, okay. And solve this. If you solve, we can get the summation of f of y equals to 68.28 Newton. Now get the value for the resultant force, that can be calculated with the help of this formula, square root of summation of f of x square plus summation of f of y square. We know the value for summation of f of x and we know the value for the summation of f of y. Substitute both this here, do the calculation, get the value for the resultant force, okay. Now once we get the resultant force, then the next task is nothing but get the inclination made by the resultant force with the x-axis. Okay, for that we know this formula: tan of theta equals to summation of f of y divided by summation of f of x. Substitute here the value of summation of f of y, summation of f of x. So get the value for theta. Okay, now depends upon the sign of summation of f of x and f of y, we can decide the quadrant for the resultant force. Okay, so if you just say here this one is negative, okay, and this one is the positive. Okay, so once we say this one positive and this one negative, means the r lies in fourth quadrant. Okay, so depends upon the sign of this one and this one, you can decide the r lies in fourth quadrant. Okay, so then next point is very important one: location of the resultant force. Let us assume that the resultant r is located at a perpendicular distance d to the right of point A in this way. Okay, let us consider this resultant r is located at a perpendicular distance d towards the right side of this point A. So here is the A point. Okay, towards the right side of this A point we have considered this resultant force. Okay, so that makes an angle 31.38. Okay, this angle and this angle is same, you can just show this angle here or here, the meaning is same. Okay, now by using the Varinga's theorem we can get the distance, this distance. Okay, now the summation of moment of all the forces about any point equals to moment of resultant force about the same point. So by using this sign convention we can proceed for the next step. Okay, now here is the first force, 80 cos of 60. 80 cos of 60, here is the first force. You have to take the moment of this force about this point. This turns about this point in anti-clockwise direction. Anti-clockwise direction. Okay, so what's about this distance? This distance with us 2 plus 2, 4 distance. Okay, 80 cos of 60 multiplied by 4 turns about this point in anti-clockwise direction. For anti-clockwise you have to consider the plus sign. Okay, now be careful about this force. The line of action of this force passes through this A point. The line of action of this 80 sin of 60 passes through this A point. Now distance becomes 0. It is not necessary to consider this force. Okay, apart from this one, if you just see the components of 120 Newton in vertical direction and horizontal direction, the line of action of both the force passes through the same point. So neglect this force and this force. Okay, simply neglect this one and this one. Now next one, 100 cos of 30, 100 cos of 30, this force with us. Extend the line of action of this force up to here and just rotate the this force about this point. Now just say distance about this point in this one in clockwise direction. So give the minus sign for this one. Minus sign is given here. Minus sign for this 100 cos of 30 multiplied by a distance with us 4. Apart from this one, if you just see the next one, 100 sin of 30. 100 sin of 30 is here. The tendency of this force to turn about this point is nothing but in anti-clockwise direction. So 100 sin of 30 multiplied by distance with us 4. So 100 multiplied by this one sin 30 multiplied by 4 will come here. So next one, 150 sin of this one, 150 cos of 50 means extend the line of action of this force up to here. And see, this is the distance with us. This distance with us 2 meter. You have to extend the line of action of this force up to here so that you can get the perpendicular distance. So this perpendicular distance with us 2 meter. And take the move, just turn this force about this point. This force turns about this point in clockwise direction. For the clockwise, do the here minus sign. 150 cos of 50 multiplied by 2 will come here. Then next one, the component of the same force in vertical direction with us, whose magnitude 150 sin of 50 with us. So tendency of this force to turn about this point in clockwise direction. Now see this one, this arrow in downward direction. The tendency of this force to turn about this point in clockwise direction. So give the minus sign for this one. Minus 150 sin of 50 multiplied by distance with us 4. Then next one, 50 with us. So 50 turns about this point in which direction? Clockwise direction. Multiplied by 2. Okay. Now this is about all the forces towards the left side. Now what's about the right side? You have to take the moment of resultant force. This resultant force about the same point. Now this tendency of this force to turn about this point in clockwise direction. That's why the minus sign is given here. 131 minus 131.4 multiplied by perpendicular distance with us d. So once we solve this, we can get the d equals to 5.623 meter, or this is towards the right side of point A. This point is very important one. if the value comes positive, means our assumption is correct. If the value comes negative, you have to write here the D lies towards the left of point A. Now here the next point in front of you, where you have to just locate that R that cuts with the base. For that you can use this relation to get the x-intercept or resultant cuts with the base. This resultant cuts with the base. Okay, this distance. Our aim is to find out this x distance. Okay, for that you can use this formula direct. Okay, so summation of moment of all the forces about A point equals to summation of Fy or forces along the vertical direction multiplied by x. Okay, so this value, this one, summation of moment of all the forces about any point, okay, means whatever the calculation done by us in the previous step, if you look towards this step, step part of this relation, okay, so pick up this one, okay, so value for this one with us is minus 738.87, okay. And what's about the summation of f of y? Summation of f of y as per calculation with us minus 68.28. Just pick up this as it is and write it here. Minus 28, this one, minus 68.28 multiplied by x. Do the calculation. So get the answer for the x. X equals to 10.82 meter. Okay. So this is the actually one method, and from another method by using the geometry, you can just get the value of the same. But as per as my opinion, this is the actually a easier method. Just remember this formula, substitute here and here. Okay, we can get the answer for the x. So once you get the value for the x, the resultant r, you have to just show that resultant r with respect to this A point. Already we know the location of the resultant force in fourth quadrant. That makes an angle 31.38 degree. Okay, the perpendicular distance with us 5.63 623 meter. Okay, and this one, this distance with us x equals to 10.8 meter. Let us start next problem. Replace the force system shown by a single force acting at a origin and couple. So in this way the force system is given. Okay, so first of all redraw this diagram, and whatever the forces available with us in the inclined direction, resolve them. So here is the first force with us in inclined direction. So resolve this force into its component. So one component will come along the horizontal direction, whose magnitude with us 500 cos of 30, and another component will come in vertical direction, whose magnitude with us 500 sin of 30. So remaining one, you have to write it as it is, because this one is the couple, this one is also couple, this force already in the vertical direction and this force with us in horizontal direction. Okay, now once the resolution of the forces is over, then get this step, summation of all the forces along the horizontal direction. For that, concentrate only on the horizontal forces. So this force running towards the left direction, this one 500 cos of 30, running towards negative side, means give the minus sign for this one, plus 600 Newton force with us running towards the right direction. Okay, so get the calculation for this one, 167 Newton. As per calculation we can get it here. Then next one, summation of all the forces along the vertical direction. For that you need to concentrate on the vertical forces. This one with us 500 sin of 30, 500 sin of 30 running vertically in upward direction, consider this force as positive. Then next one with us here, this one vertically in upward direction, and another force with us here 400 Newton vertically in the downward direction. Okay, so this one in downward direction, that's why the minus sign is given here. Okay, do the calculation, get the answer for the same. So 150 Newton will come after doing the calculation. Now in the next step you have to do calculation for the resultant force. So resultant can be calculated with the help of this formula, summation of f of x square plus summation of f of y square equals to this one. We know the value for summation of f of x, we know the value for summation of f of y. Substitute here, do the calculation, get the value for r. So r we can get 224.5 Newton. So after that get the inclination made by this r with the x-axis. Okay, So for that, this is the relation with a summation of f of y by summation of f of x. Okay, do the calculation, get the value for angle. So angle we can get here 41.93. Now depends upon the sign of summation of f of x and f of y. We will decide the quadrant for the r. Now if you just see this one is positive, this one is negative, means we can say the r lies in again fourth quadrant. Okay, now if you just say in the next step you have to get the location of the resultant force. Okay, now for that let us assume that the resultant force r is located at a perpendicular distance d to the right of the origin o. So origin o is here. You have to just get the location for this resultant force. Okay, d is here. The next one is nothing but Varigna's theorem. Apply the Varigna's theorem and get the value for this one d. For that, just focus on one by one force carefully. So 600 Newton force is here. 600 Newton force is here. Okay. Now you have to take the moment of this 600 Newton force about this O point. For that, extend the line of action of this force up to this one vertical axis and say this is the perpendicular distance. So perpendicular distance is here 1.5 meter. You have to take the moment of this 600 Newton force about this point. So 600 Newton force multiplied by distance with us 1.5 meter. So this turns about this point in clockwise direction. So give the minus sign for the same. Next one, 400 Newton force with us. The tendency of this force to turn about this point in clockwise direction. Okay. So this distance with us 4 meter. So what's about this one? This distance 4 meter and the tendency of this force to turn about this point. For that, extend the line of action of this force up to here. We can get the perpendicular distance. So this turns about this point in clockwise direction. For clockwise, you have to give the minus sign. Okay. So that's why the minus sign is given here. So minus 400 multiplied by 4 distance with us. Okay. Now next one, 500 sign of this one, so pass of 30. You have to extend the line of action of this force up to here. Okay. And just say the tendency of this force to turn about this point. In which direction? This turns about this point in anti-clockwise direction. The tendency of this force. When I just trace the line of action of this force up to here, the tendency of this force to turn about this point in anti-clockwise direction. So anti-clockwise direction, give the plus sign for this one. So force multiplied by distance. So distance with us, how much? This one 2 meter with us. 2 meter distance with us. Then next one, 500 sine of 30. Turns about this point. In which direction? This one again in clockwise direction. Extend the line of action of this force up to the axis or up to the perpendicular distance. We can get the perpendicular distance between the line of action of this force and the point about which the moment is to be calculated. So this distance we can get here 2.5 meter. So tendency of this force to turn about this point in clockwise direction. That's why the minus sign is given for this force. So minus 500 sine of 30 multiplied by 2.5. Now next force. Now important thing here, whenever we consider the couple, whenever we found any force in the problem that includes the Newton meter unit, and if that force is represented by this one couple sign, then it is not necessary to multiply by any distance to that couple. Okay, pick up the value as it is. So see the direction of the rotation of this one. This turns about this particular point in anti-clockwise direction. So for anti-clockwise direction, just consider the positive sign. Don't multiply by any distance to this one. Similarly, here the 100 Newton meter force with us. The tendency of this force to turn about this point in clockwise direction. Don't multiply by any distance to this one because already the distance is included here. Newton meter, that indicate the couple. Okay. So here this turns about this particular point in clockwise direction. That's why the minus sign is given here. Minus sign. So all the forces considered by us. So equate with the right side. So right side indicate here the moment of resultant force about the same point. So what's about the moment about the at this point? The tendency of this force to turn about this point is nothing but the in clockwise direction. For clockwise, give the minus sign. And what's about the distance? It is the distance with us. Okay. So here we can get the minus 224.5 multiplied by d. So if you equate and do the calculation, what do we get here? D equals to 9.617 meter. Means our assumption is right. Okay. So whatever the assumption we are written here, R is towards the right side of that point O. This is the correct assumption. Okay, so here you can just mention D equals to 9.617 meter to the right of O. Now see the location of the resultant. So here we want the couple value with respect to which one? With respect to origin. Origin point is here. So whatever the forces given in the system, you have to take the moment of all the forces about this point, okay, and we can get the moment value. For that, if you look to us here, couple M is nothing but F multiplied by D. Now to replace the system by the force couple at a point O, we need to shift the resultant force R equals to 224.5 Newton to origin O by introducing a couple M. Now if I locate this force, locate this resultant force already we get in the previous step. So here is that resultant force. Magnitude for the result force with us. If I locate that result force directly at the origin point, because of that shifting, what's about the actual value of the moment of couple will come just here. So here moment of couple force, moment is written here like this one. Moment equals to force multiplied by distance. So what's about the force? Force equals to minus 224.5 multiplied by what's about the distance? Distance already we get from the previous step 9.617. Okay, so tendency of this force, assumed force to turn about particular point is in the clockwise direction. That's why force multiplied by perpendicular distance, we can get the moment of couple at that particular point. So in this way you can get the value for the moment of couple. You have to simply this one, you have to just simply shift the position of this one and or just see the magnitude of this one. It's not necessary to actually, if I just give the position of this one passing from this one, then you need to just get the value of moment. How can you get the value of moment? For that you need to multiply by this distance to this force. So same thing actually done here. Minus 224.5 you multiply by 9.617. Okay, you can get the value for the moment of the couple. So 2159 Newton meter we can get it after doing the calculation. Okay, so resultant force couple at the origin here in this way that the force is shown. Now move to us next problem on the same topic. So let us start with the next problem. Replace the system of forces and couples by a single force and locate the point on the x-axis through which the line of action of resultant force passes. So here in this case the problem is given like this one. It includes the couple at this spot, this one. Apart from this one, two forces are there, this force and this force. This force already in the vertical direction and this force with us in inclined direction. Okay, so as per the first step, it is very important to resolve the forces. If the any inclined force available with us in the system, then you need to resolve that force. Okay, so this couples you have to show as it is. As it is, that couple will come here, this one. You have to just redraw this diagram. Now focus on the inclined force. Inclined force is here 6 Newton. Okay, you have to resolve this 6 Newton force into its component. One will come along the horizontal direction, another will come in vertical direction. So what's about this force? 6 cos of 38.66 and this one 6 sin of 38.66. Okay, now once the resolution part is over, to get the value for the summation of all the forces along the x direction. So what's about this one? Focus on the horizontal forces. So here is the first horizontal force whose magnitude 20 Newton. Okay, running towards left direction. This one force, this force running towards the right direction. So two forces with us in horizontal direction. So what's about this one? Minus 20. Why the minus sign is written here? Because 20 running towards the negative direction. 20 running towards the this direction, means you have to give the minus sign for the same. Next one 6 cos of 38.66. okay, this running towards the right direction, that's why the positive sign is given for this one. Do the calculation and you can get the value for the same as minus 15.315 Newton. Now get the calculations or do this step, summation of all the forces along the vertical direction. For that you need to concentrate on the vertical forces. So first vertical force with us here, whose magnitude 6 sine of 38.66. Okay, so that force we have written here. Then next force with us, whose magnitude 12 Newton with us. Just write this force here. Okay, and do the calculations. Once we do the calculation, you can get summation of f of y equals to 15.748. Now do the calculations for the resultant force. So resultant can be calculated with the help of this formula, summation of f of x square plus summation of f of y square equals to this one. Okay, so after a substitution of this one, summation of f of x and f of y, we can get the resultant r equals to 21.97 Newton. So once we do the calculation, we can get the inclination made by resultant force with the x-axis. So tan of theta equals to summation of f of y divided by summation of f of x. Substitute the value of this one, summation of f of y, summation of f of x, to get the value for theta. Theta equals to 45.8, okay, degree. We can get the inclination. So depends upon the sign of this one, sign of summation of f of x and summation of f of y. We can decide the quadrant. So here we can get the minus, here we can get the plus, means the r lies in second quadrant. Okay, so here depends upon this one, you can decide the r lies in second quadrant. Then very important step is to locate the resultant force. So to locate that resultant force, okay, so assume that the resultant r lies towards the right side of point O at a perpendicular distance d from this point O. Here clearly this assumption is written. Let us assume the resultant force r is located at a perpendicular distance d to the right of origin O. Now by using the Varigna's theorem, summation of moment, this one, summation of moment of all the forces about any point equals to moment of resultant force about the same point. Okay, so what's about the this one, 20 Newton force? This is the first force with us. You have to take the moment of this force about this point. So what's about this one? This turns about this point in anticlockwise direction. For anticlockwise direction, 20 multiplied by 2. Okay, so what's about the next one? Next force is here, 12. The tendency of this 12 Newton, just extend the line of this force up to here. Okay, now take the moment of this 12 Newton force about this point. So what's about this one? This turns about this point in anticlockwise direction. For anticlockwise, give the plus sign. So 12 multiplied by 3 will come here, because you have to extend the line of this force up to the point where we can get the perpendicular distance. Here is the perpendicular distance. So this distance already with us here, 3 meter. That's why multiply by 3 is here. Okay, for this force. So what's about the next one? So next three forces are very important one. The couple is shown here. Now see the tendency of this couple to turn about this point in anticlockwise direction. Don't multiply by any distance with this couple. Already that distance is included in that couple value. Okay. So here 35 Newton with us. The tendency of this force to turn about this point in anti-clockwise direction. For that, consider the positive sign. Next one, 15 Newton meter couple with us. The tendency of this force also to turn about this point in anti-clockwise direction. So give the plus sign for this one. So next one, 20 Newton meter force turns about this point in which one? In clockwise direction. Give the minus sign for this one. Do the calculation. Okay. Before that, see towards the right side. Right side of this one, moment of resultant force about the same point. So here is the resultant force. Resultant force, the tendency of this resultant force to turn about this point in which direction? This one in anti-clockwise direction. For anti-clockwise direction, consider the positive sign. Okay. So 21.97 multiplied by d with us. Do the calculation, check the value for d. So after doing calculation, we get the value for d equals to 4.825 meter. Okay. Now next point is to find out this one x value. Okay. For that you can just get the solution from this geometry or by another method. So you have to use this formula, summation of moment of all the forces about that particular point equals to summation of f of y multiplied by x. To get the x intercept or that particular force cuts with the base, we can just say that is nothing but the x direction, and we can get the value for the same with the help of this relation. So summation of this one, moment of all the forces about any point. This actually side already with us. Do the calculation for this particular side. Okay. So after doing calculation, we can get that value as 106, this one 106, and towards the right side the summation of f of y, this term already with us, just substitute here 15.748 multiplied by x. After doing calculation we can get 6.73 meter. Okay, same we can get from the geometry, but as my opinion this is the simple one. Okay, so this one is very simple one. Use the single formula, just substitute the value for this one, and get the value for the x. Okay, now once we get all this detail, now last task is nothing but the location of this resultant force. Okay, so already we know the information regarding this resultant force. Here the angle theta with us, the magnitude for this one with us, we know the quadrant, we know this perpendicular distance. So in this case